Is this has this month gone by fast for you guys? I was looking at my grading timeline just so you guys know. Progress reports are given to all freshmen at every juncture during the year where progress reports can be given. They are mandatory to be given. So don't think just because you got a progress report you're doing bad. If you're a freshman, it's required that we issue progress reports, and report grades are closed this Friday, which means technically if I could get your test in, I would. I'm not sure if I'll have it graded in time, but your progress reports will be due for the teachers by the end of next week, which means you guys should be getting it in the mail the following week. Sophomores and up, it's recommended if you're struggling. Otherwise, you shouldn't be getting one unless your teacher just does it for everyone, which sometimes that happens too. All right, you guys. So just a refresher, you can keep it your page where it's at. I wanted to refresh your memory on what we learned the other day that I highlighted for you guys. The Supplements Theorem required that, so the word Supplements Theorem and Complements Theorem is going to look really familiar and or sound confusing when we mix it with these other theorems that are called Congruent Supplements and Congruent Complements Theorem. So up above, just to refresh your memory, I could use Supplements Theorem if I was given either that it was a linear pair in the given part, or that you had a picture of a linear pair like this. Okay, so then my conclusion was, given a linear pair, I can conclude that the measure of the two angles are supplementary angles, so they add up to 180 degrees. But again, I had to be given it was a linear pair or a picture of a linear pair. For the complements theorem, we began with two lines that are perpendicular, or a figure where you guys had FG is perpendicular to GH, and your conclusion was that the angles added up, the smaller angles inside, two adjacent angles added up to 90 degrees, or in the picture, you could make the same assumption so long as you began with it was perpendicular. Okay, so that was supplements theorem and complements theorem. The definition of supplementary angles would be something that you would use if you were given that the angles were supplementary and they didn't mention linear pair or give you a picture of linear pair. Okay, the definition of complementary angles, same thing. They gave you that measure of angle 1 plus measure of angle 2 equals 90 degrees without any mention of a right angle or perpendicular. Okay, so fast forward to today's lesson. Okay, a couple things that I'm going to have you highlight or underline is that you do have to realize that the reflexive property, these properties, symmetric property, transitive property of congruence, hold true for angles as well, which means that what you guys were using for segments, saying like segment AB is congruent to segment AB by reflexive property of congruence, can be used also for angles. Angle 1 is congruent to angle 1, reflexive property of congruence. So they also apply to angles. And then the other three that I'd like you guys to highlight is the congruent supplements theorem you have to know. Complements is spelled wrong. It should be with the E instead of an I. Vertical angles theorem we covered. But those three on top that have a special name to it, and then the congruence properties above. We'll talk about the congruent supplements and congruent complements theorem, and I'll explain that. The ones below that, I would like you guys to be familiar with, but you don't have to memorize that for the test. Just make sure it makes sense to you. You're not going to be asked to prove where you guys have to use any of those theorems right there. Okay, so in the above space that you guys have, or if you guys don't want to squeeze it in and you want to have it on a sheet of paper, let me break down the congruent supplements theorem and congruent complements theorem as a picture to you. So let's start with congruent supplements theorem, which you guys can abbreviate as the congruent symbol, supplements, and then THM. Okay, so for this one, you'll notice that here's a really key word that I want you guys to focus on. This theorem has the word congruent in it, okay, whereas the supplements theorem you guys had before doesn't mention congruence. And so the supplements theorem, without the congruence in front of it, talked about angles. Your conclusion was about angles adding up to 180 degrees, hence the supplement. This one is got the word congruent to it, okay? So let's see how that's different. So say you guys were given all of this information. You were given that you were given a picture of a linear pair. So angle 1 and angle 2. You're given that angle 1 and angle 2 are a linear pair. Okay, you're also given another picture of an angle, an acute angle to the right of that. Okay, so here's another clue, you guys, for this one. You have 3 angles that you're talking about instead of just 2 angles. You have angle 1, 2, and 3, whereas Supplement's theorem only talks about the angle 1 and 2. Okay, so there's 3 angles involved. We can draw conclusions from the picture that 1 and 2 are supplementary by Supplement's theorem from the theorem the other day, because it's a linear pair. And they also tell you that angle 1, so this is all part of the given, and angle 3 are supplementary to each other. Okay, so my question to you guys is, what is your conclusion? And the key word here is congruence. Okay, so congruent supplement theorem, your conclusion is something about something being congruent. Okay, what do you guys think you can say?
Angle 2 and angle 3 are congruent.
Yes, very good. So angle 2, and actually maybe I'll switch the color here. Your conclusion is different in a different color, but angle 2 is congruent to angle 3. That's it. So the way you tell the difference between just regular supplements theorem is you're given a linear pair, your conclusion is that they add up to 180. It has something to do with just the supplement part. The congruent supplements theorem has the word congruent in it, so your conclusion has something to do with the congruence, and there's 3 angles involved, okay? And it's almost like transitive property in a sense that you have angle 1 being compared to angle 2 and being compared to angle 3 as supplementary. Okay, so, and then you drop out the angle 1 in your conclusion, and your conclusion is 2 is congruent to 3. Okay, so in a similar way, you guys have the congruent complements theorem. Okay, and in your given picture, you have a 90-degree angle or 2 lines perpendicular to each other. You have angle 1 and angle 2 here. And then again, with the congruent complements theorem, you have an extra angle called angle 3. Let me zoom in on that. Okay, you know for a fact that when I'm given this picture, and I should really draw a 90-degree here, that if those lines are perpendicular to each other, you guys can conclude these angles must add up to add up to 90 degrees by Complements theorem. Remember, the Complements theorem on its own just simply, it's a conclusion about the angles being complementary in a right angle. Okay, and then with the congruent complements theorem, you're thrown in an extra angle, and you're told that angle 1 and 3, angle 1 and angle 3 are complementary to each other. Your conclusion, which we'll do in a different color, your conclusion is what, you guys? In a similar way, what can you conclude? Okay, and we know
2 and 3 are congruent.
Okay, yeah, so same thing. Angle 2 is congruent to angle 3. So again, once again, with the congruent complements theorem, you have the conclusion of congruence in your theorem. Okay, so I'll give you guys a minute to write that down if you need to. We're going to practice with 2 fill-in-the-blank proofs. Sometimes with these proofs, like I have a vision of what I would do, and it's different from what the fill-in-the-blank proof does. So part of the fill-in-the-blank, sometimes students are like, oh good, it's fill-in-the-blank. But you have to go with the reasoning that that person did. And sometimes there's more than one way to do it, and sometimes that wouldn't be the way that you picked, but it still needs to make logical sense to us. So let's start with the easier one on the bottom right here. Okay, so very similar to what I did above. Kind of what I did above was I would say kind of a verbal paragraph proof where you guys are writing out some of the stuff that you have, whereas this is a 2-column proof of something very similar. Okay, so angle 1 and angle 2 form a linear pair. So what I'm going to do is circle linear pair. And to me, whenever I see that in the given, I'm thinking just plain old supplements theorem. Okay, I can conclude that measure of angle 1 plus measure of angle 2 is equal to 180 degrees. Okay, so kind of like keep that in mind. And then you're also given that 1 plus measure of angle 1 plus measure of angle 3 is 180 degrees. Again, if I look at the picture, yes or no, you guys, because this was the confusion in the last period. Would you guys describe angle 1 and angle 3 as a linear pair? Yes or no?
No.
Okay, good if you guys said no. That means that your reasoning for that one cannot be supplements theorem, okay? So some people are like, oh, supplementary, or sorry, not supplementary, but it's supplements theorem. It can't because it's not about it being a linear pair. All right, so let's get to statement B. In statement B, when I get there, I'm like, okay, well, we're trying to prove angle 2 is congruent to angle 3. That's what Mrs. Kim was explaining up above. So we know that this is eventually about the angle 2 and angle 3 being congruent, so kind of keeping that in mind. But for B, what do you guys think? If it's a linear pair, then my conclusion is that what two angles must add up to 180 degrees?
1 and 2.
1 and 2. And that's by Supplement's theorem because of the linear pair statement that was given. Okay, so step C is now, okay, I've used the information on the linear pair. Now if I look at the second part of the given, measure of angle 1 is equal to 180 degrees right here in the given. What is my reasoning? So the last class had a really hard time with this one. What is my reasoning if I'm given that 1 plus 3 is equal to 180 degrees, that you would know angle 1 is supplementary to angle 3? What do you guys think the reasoning is? Nice, you guys. Yeah, so this
Definition of supplement.
yes, definition of supplementary angles. And the last class, I had a lot of people say supplements theorem, but 1 and 3, once again, if you look at the diagram, are not even a linear pair. So we can't say that. We can't use supplements theorem for it. So we go back to the given, and the given says that they add up to 180. So if it's something really where you're like, what does it mean to add up to 180? It means that the angles are supplementary to each other, and that's your conclusion. Then the really basic truths are definitions. So definition of supplementary angles. And finally, since we know 1 is supplementary to 3 and 1 is also supplementary to 2, the conclusion is that angle 2 is congruent to angle 3. And that statement right there, angles supplementary to the same angles are congruent. What is the title that you guys can use for that? What's that theorem?
Congruent.
Uh-huh. Complements or supplements?
Complements.
180 degrees or 90 degrees were we talking about? We were talking about
Supplements.
supplements, yeah. So congruent supplements theorem. Okay, so an example of a proof that I might not have done exactly in this manner because you guys have the knowledge of complements theorem, which you can incorporate into the proof on the left. This proof actually does prove the complements theorem along the way. So I might not have done this in as many steps because I knew the complements theorem, but if I didn't know the complements theorem and I worked it out this way, this is also fine. But the point is that if a proof is given to you like this, are we able to reason through how they got from step 1 to step 2? So let's take a look. Okay, AB is perpendicular to BC. Okay, so I'm going to, with that statement, it's like, well, what can I mark off on the diagram to say that AB is perpendicular to BC? So many of you guys would say, oh, just draw in a right angle. Okay, 1 and 3 are also given as complementary. We're trying to prove 2 is congruent to 3. So what I want to point out is that the steps that were taken on the right to prove virtually the same thing, the left is something to do with congruent complements theorem, and then the right is congruent supplements theorem. You'll notice that the proof in step 2 used supplements theorem, and it made the proof really short. Okay, on the left, they don't use that, and it makes the proof really long for complements theorem. So, so again, just a note, there's more than one way to do the problem. Okay, so AB is perpendicular to BC. I'm going to say that is given to me. Okay, so if I asked you guys, go back to the beginning, when I say two lines are perpendicular, what would you guys say they form? It's like, okay, yeah, so they form a right angle. So that tells me that in my diagram, when I marked perpendicular, I went to mark off this right angle. So what it does is it forms a right angle. So angle ABC is a right angle. So if it's something that's really basic, it's like, okay, by definition of perpendicular, if I were to draw two perpendicular lines, I'm drawing a right angle. Okay, so that's by definition of perpendicular. And so if I asked you guys, can you define for me what a right angle is? What would you guys say? Okay, 90 degrees. Okay, so measure of ABC is equal to 90 degrees by definition of a right angle. And so now, okay, well, this is all great, but we have a relationship between 1 and 3 in our given statement right here. Talks about 1 and 3, and then our proof is about 2 and 3. So there's no discussion of 2 anywhere. So somehow I have to incorporate 2 into the picture. Okay, so if you guys look at the next statement, they said angle ABC is comprised of 1 and 2, the sum of measure of angle 1 and the measure of angle 2, sum being the key word. Okay, what allows me to say D, measure of angle ABC is equal to measure of angle 1 plus measure of angle 2. Very nice, angle addition postulate. A piece plus a piece is a whole. So angle, I added 2 angles to make it equal to, added 2 pieces of an angle to make a bigger piece, angle addition postulate. Okay, so next step is I look above and I see that measure of ABC and measure of ABC are in steps C and D. Okay, my conclusion is in E, 90 degrees is equal to 180, or sorry, 90 degrees is equal to measure of angle 1 plus measure of angle 2 by substitution, or by what other property could you guys have used for that?
Transitive.
Transitive, perfect. And then step F is knowing that measure of angle 1 plus measure of angle 2 is equal to 90 degrees. Your conclusion is that 1 and 2 are complementary. What do you guys think the reasoning is for that?
Definition of complement angles.
Yes, definition of complementary angles. And we notice we didn't use complements theorem because our conclusion isn't being drawn from the fact that it's a 90 degrees, but the fact that the step before that, it just said it added up to 100 or added up to 90 degrees. Okay, and so lastly, the second part of the given that was not used yet is that angle 1 and angle 3 are complementary angles, which was given to us. Okay, so notice in step F and G that angle 1 is being compared to angle 2 and angle 3 as being complementary to each one of those angles. And the conclusion is that 2 must be congruent to 3. What's the reasoning for that? Perfect. Congruent complements theorem. Okay, I would say, you guys, that this type of proof is pretty complicated. You're not going to be expected to do one of this length on your own. And if you, this is kind of similar to what I think some of your fill in the blank proofs is, but I still have to take a look at it, and then I'll confirm and kind of give you guys a little bit more tips on how to study for it when we get there. Can I have you guys find set 1 and 2? Someone asked, what is the homework? The homework is on set 1 and 2, just more practice for proofs. So if you guys can find that, and then I'm going to do one proof with you guys just to kind of get you guys started on it. So set 1 and 2. And I believe this is number 3 from set 1, I want to say. I think it's set 1. And when you guys find it, can you go ahead and fill in all your givens and draw a picture for me? And if you guys are done writing in the given, you'll notice that you're given a lot of information. So there might be more than one way to do this problem, or some of your steps might go in a different order, and that's okay. So anyone want to give a suggestion about where to start with this problem? We're trying to prove that 3 is congruent to 4. Any suggestions on where you guys would start with this for this problem?
Angle 1 and angle 2 are complementary.
Angle 1?
Or not complementary, congruent.
Angle 1 and angle which one? Oh, and angle 2 are congruent. If you guys put that in, that is correct. Like you would say 1 is equal to 2. That's right. Yeah, so we could write that out if we like. Does anyone see, and that wouldn't be incorrect, Gavin, but I guess in a shorter number of steps, do you guys notice how both of these are equal to 80 degrees? Okay, so if they're both equal to 80 degrees, could we say that they're equal to each other? I think someone, Cody has it in the chat, but measure of angle 1 plus measure of angle 3 is equal to 4 plus 2. And so say if Gavin had that extra step in first, then he can use that extra step to incorporate into my step 2 as well, so which wouldn't be incorrect. Okay, so what would the reasoning be for this one? If they're both equal to 80 degrees, why must they be equal to each other?
Substitution property.
Yep, substitution property, good. Or transitive, I think, which is what Cody wrote. That's fine as well. Step 3, or actually I'm gonna put / transitive property. Here's one question that I got. Someone said I get confused over when to use substitution and transitive. And for that moment in time when I was talking to one individual, I knew that certain steps you can use both substitution or transitive, like step 2. But why in step 3 would you not be able to use transitive property? So for example, step 3, I also know 1 is equal to 40 and 2 is equal to 40. So I'm going to plug in 40 here and plug in 40 here. Okay, so 40 plus measure of angle 3 is equal to measure of angle 4 plus 40 degrees. Can you guys use transitive there? Would that be a case of no? Yeah, so this is an example of step 2. You can use either one, but step 3 is only substitution property. And lastly, what's the last reasoning for why 3 is equal to 4? What's that last reasoning? Good. Some of you guys wrote subtraction property of equality. I think I wrote too many letters there.
Miss Kim,
Yes.
is there ever cases where you can use transitive property but not substitution property?
No, that's a good question. Yeah, you can. Anytime you use transitive, you can use substitution.
So why can't we just get rid of transitive and just stick with substitution?
Yeah, I guess it's like transitive is a special case of substitution, I would say. So for some people, they prefer seeing it that way and like distinguishing between the two. But yeah, if you wrote substitution property all the time, you wouldn't be incorrect.
Okay.
All right, you guys, it seems like a lot of people are having Wi-Fi issues. I don't know if a network is having issues, but most of us are all on Spectrum, right? Because that's this area. But if you're not, then it might be. So someone asked, so the quality of congruence is the same. Congruence is like if you had angle 3 is congruent to angle 4, then, and I was doing everything in, if I'm using equations, I'm sticking with equality. If, for example, my problem initially was given incongruence, I'm going to convert to equality first before I use any equations in it. Because we never solve like a congruent statement. We solve an equality statement, which is an equation. Does that make sense, Kehlani? Yeah, and of equality, just because these are all equal signs, you would use equal signs with angles also if you had an M in front of it. So the congruent symbols don't need the little M in front of it because it's not talking about measurements. All right, you guys, so that's all the time we have. Again, let me know if you guys are struggling on anything. Email me, let me know. Don't wait until the last minute because you guys are my odd period. So you guys have the test first this Thursday. So Tuesday, Wednesday, we have tutorials. If you need